Good morning, ETH Denver. This is the Proof of Location panel. My name is Matthew Aaron. I'm the host of Crypto 101. And before we start Proof of Location, I want to introduce our panelists. First, Mr. Ari Tro. Can you please introduce yourself, sir?
Hello, my name is Ari Tro. I'm the CEO and the founder of XYO. It's Oracle for location and for metadata from the physical world.
Mr. Marcus Delano East.
Hey, good morning, everybody. I'm Marcus East. I'm the Chief Technology Officer for National Geographic.
Thank you, sir.
Howdy, everyone. My name is Cameron Shorg. I work at Dish Wireless, and I am the business development lead for our IoT and smart cities initiatives.
Welcome, gents. Thank you very much for being here. Before we go into Proof of Location, what we want to do is we want to set the stage. We want to talk about the current issues in location data in general. Mr. Ari Tro, can you please walk us through the issues in location data?
Up till now, we've primarily been focusing on the accuracy of data. So if you look at GPS, you look at navigation systems, or assisted GPS even on your phone where it uses fingerprinting and stuff, we've always been focused on accuracy. And you always trust the sources that you get the data from. So it could be the satellite, and it's your own phone, and you're looking at that. But it's a one-way heuristic. So you're actually reading data from satellites. For GPS, you're actually looking at fingerprints from Wi-Fi or from Bluetooth and that sort of thing to get the location. But it doesn't increase the certainty at all. And one of the problems we run into is certainty of location, especially for audit trails or for anything which actually matters. The example of this is Pokemon Go, where you can go and collect all the Pokemon in Africa by just spoofing the GPS on your phone fairly easily. They can look at, well, how fast did it get you there? So if you teleport it to Africa, they can say, well, that's not real, but you can fake a path to Africa and then go get the Pokemon Go. So increasing the certainty of location and also the indoor location aspect of it is kind of difficult. So that's always been a problem, especially when it comes to decentralization, because when decentralization, if you have multiple sources of data, so you have tens of thousands or even millions of people who are all producing location data and metadata that's associated with those locations, how do you know they were actually where they say they were? And so how do you trust trustless data? And that's kind of what XYO does, is we work on the certainty of data that's location and metadata from the world that is not from a known trusted source like your own phone or your own system.
Right on. Is there any current issues with location data with your two companies? Marcus?
Yeah, I would build on what Ari said in that one of the things that I think about a lot is the credibility of the data. So for example, if you're collecting information about pollution in a particular location, would you trust the local government to provide that data to you? Because they have an incentive to provide data that may not be 100% accurate. So if you're trying to do something that is based on science and fact, you might want to have some sort of independent, distributed, trustless access to data so that you can have absolute confidence in it to help you make the right decisions. Not that I'm suggesting governments lie about data, but sometimes it happens.
Yeah, and I would say as we look at all these Internet of Things devices that are going to be connected, obviously location is extremely important, and Marcus kind of hit the nail on the head there as far as if you've got all these devices connected to the internet and you can't rely on their location at all, then you can't get a lot of the insights that you're deploying these devices out there in the first place. So, location data kind of is the fundamental ground layer for any other information to have any contextual importance behind it.
Thank you, gents. So we know that there's current issues with location data. You can spoof Pokemon Go. You really don't know where. You can spoof GPS to tell you where things aren't where they're supposed to be. Mr. Ari Tro, can you please tell us some solutions and some things that maybe XYO is doing to help foster more confidence in GPS or location data?
So the model that we use for our protocol at XYO is really, we call it bound witness and proof of origin. And so it's all relative data, because one of the things that we found is it's really difficult to substantiate something absolutely. So for example, do you know you're actually in Denver right now? The only reason you think you're in Denver right now is because you have other relative data points around you that suggests that you're in Denver, or you have a history trail of you were at the airport and you drove from the airport to here. But all the facts that you actually know from a mathematical standpoint is that you're actually sitting in a chair in a room that looks like the room that should be ETH-Denver and so on and so forth. So the way a human mind works is we collect tons and tons and tons of relative data over time, and then we're really good at projecting that relative data into absolute truths. And we started off by injecting an absolute truth into it. So, for example, if I want to say, well, where is Marcus right now? I believe I'm in San Diego, at ETH-Denver, and I know for a fact that he's, within proximity of me. So with the commutative property, I can say, well, he's within proximity of me. So what XBIO did was we were setting out to collect tons and tons and tons of these relative data points, starting off with proximity and then also other metadata that is co-optable because it's a two-way street. And so if, for example, if Marcus and I took a selfie together and we both signed it, now we have proof that we were actually within proximity of each other. We don't have proof we were at ETH-Denver, but we have proof that we were there. On a selfie, you can't really necessarily have the time in there. So what we do is we put this in a ledger that's immutable. And now I can see, at least from a relative standpoint, that this selfie I took with Marcus was after a selfie I took with somebody else and before a selfie I took with a third person. So now I know, at least from a relative standpoint, where it was in my timeline. So given all these relative data points, we can actually make a lot of conclusions that are close to zero knowledge proof to be able to prove data and the position of metadata somewhere in our physical universe.
Cameron, would you like to continue with that to tell how Dish Wireless could use such a concrete data, location data solution?
Yeah, well, I think as we build a nationwide network, there are tens of thousands of different pieces of hardware that are going to be out there. So just from like an operational efficiency standpoint, accuracy of location is going to be critical for us. And then as we connect customers to that, and we have hundreds of thousands, millions of different devices connected to the network, knowing where they're at contextually amongst our network so we can better do network slicing and allocate resources specifically to certain parts, certain edges of the network, so on and so forth. Yeah, accuracy of that location and the reliability of that is of utmost importance.
Marcus, when we were talking offline, you told me about maybe National Geographic covering the entire planet with sensors. Could you tell me a little bit more about that? Tell everybody about that, and how would that work?
Yeah, I'd be delighted to. I mean, we believe that the more that people know about the planet, the more likely they are to care about the planet. So right now there's lots of discussions about different aspects of our existence, climate change, temperature, sea levels. And we think that the right way to inform that discussion is to provide data. Because if you can have data to inform those conversations, it then provides credibility. The challenge is, if I take one of our use cases, we have explorers that have developed some technology that detects sounds in areas that are vulnerable. So for example, you can have a little device that's in a rainforest, and if it hears someone start a chainsaw, it triggers an alert to us that says, hey, somebody may be about to do some illegal logging. The challenge that we have is that we don't have enough people to climb trees in rainforests to go and put these things up. And we also want to have this around the whole world. So one of the things that excites me about the work that XBIO is doing is this idea that if you can really crowdsource that data, if you can get many, many people around the world participating in creating that data and providing those heuristics, you can build that searchable vision of the world. And then policymakers should make decisions about where to put a road or where to build a building based on data. Like, what is the impact on pollution? What is the impact on biodiversity? And that's my passion, and that's why I'm really excited about developments in this space.
And so to top off on that, I think what's most exciting about, and something we're all excited about around blockchain technology, is like this incentivization layer that maybe wasn't there before, and the economical value is so abstracted from the case that Marcus is talking about of covering the whole world with these IoT sensors and getting a pulse of the planet or some sense of what's going on everywhere. The incentivization layer wasn't there to deploy devices, to collect that data, so on and so forth. And I think what's really cool about blockchain technology specifically is that we now have the incentivization layer there to incentivize these things to happen and make a better world for all of us because of it.
Talking about having the IoT and having different devices all over the world, confirming location data. Ari and I were talking on a podcast recently, and we were talking about a hypothetical example of Amazon, delivering packages via drone, and how those things are going to be delivered at your house, signed for, and the location data maybe from something in your home. Can you tell us about like maybe a vision of the future of XYO kind of linking the world with location?
Well, the example of logistics is one of the simplest examples from a business, and how does this actually make something of value or direct value for the world, and be able to pay for a system like this. And right now, I'm sure if you guys have had a delivery of an Amazon package, sometimes at the end of the tracking system, they have a photograph of where it was delivered. So here's a photograph of your hello map in front of your apartment or your house, and there's a package on it, and it's kind of like, it's their proof that they delivered it. But I've had that problem before where they delivered it to a construction site, which was a house before where I lived in, but I picked the wrong address. But they have a picture of it. So that's a very blunt force way of doing that, is just to take a picture. You can't really take a picture of the house because then now there's some privacy concerns. But being able to have a ledger, an audit trail that actually establishes that mathematically that it was actually delivered, and even gives you more data points along the way of where it was. You can even add in there other things of how it was handled. So I don't know if you've ever had somebody, throw something which is breakable over a fence when they deliver it for you, the post office, and it breaks. So in our system, what we can do is, besides having these location spots in there, we can collect other sensor data. So if there's an accelerometer in there, the sudden G-force stop, we can have in there. So it's like, oh, this thing has exceeded a certain G-force or a certain temperature. So anybody who receives something, whether it's ice cream at grocery store, and you want to know if it melted somewhere along its voyage, or a TV hasn't been dropped somewhere along its voyage, all these little metadata points can be put in there, and then also it's unequivocally true that these sensors actually triggered. So it isn't just, well, when you get to the end, does the box look damaged, which is very, very unlikely to tell you what happened to it over the journey. Was it somewhere humid? Was it somewhere warm? Was it dropped? Was it all these different things? So I think the practical use of this technology in logistics is something which is the shortest distance to revenue for us, for example. But from a changing the world standpoint, I don't think it's as important as some of the other things we can do with it, but it definitely helps us build out the network and make it bigger.
What are some of those other things we can do with it, sir?
Well, like some of the things, for example, that Marcus was talking about, where you don't trust a country, for example, potentially for that data, or you've seen this in research papers, that people will have to retract something, whether it's a drug discovery that they believe was fine, but what they ended up happening was they removed certain data points from the study to make their point valid. And so when a person starts a study for a new drug, if they have to go and put all the different people who are participating in there, and then be able to track their location and their history and all the metadata that comes along with it, at the end, they can't say, well, we removed these 2 or 3 people from it, because it didn't support our theory. They have to actually either throw out the entire study or present all the data. So basically, it ties all that data together. So the idea of being able to keep people honest in things that really matter, whether it's drug research, whether it's global warming research, there's all these different things where I don't think people realize often the capitalistic instincts for humans often make data manipulation something which is a very common thing.
Cameron, would you like to go into a little bit more about this metadata and how maybe District Network could be part of the collection of that data?
Yeah, well, obviously when you've got tens of millions of different IoT devices, all needing connectivity, they're sending all that data over, or will be sending all that data over our network. And it puts us in a prime location to provide services around that data, but also to aggregate that data, create insights around that. Specifically thinking about smart cities, you've got all these different smart city sensors. One might be an air quality sensor that's sitting outside on all these light poles or something like that. But then a block down the road or a different part of the city, you've got traffic monitors and maybe a smart sidewalk sensor or ambient noise sensor, so on and so forth. And for the city to be able to do better urban planning, so on and so forth, you need to collect all this data to provide context around it and obviously eventually insights. And I think, specifically the network provider is positioned very well, I guess, to aggregate some of this, to provide some services around that. Yeah.
Marcus, with this metadata that we will be collecting, I'm assuming it's trustless, of course, but there's going to be a lot more confidence in this data. A lot of people are still denying climate change. A lot of people are denying that, that we actually have to make a change. How will this help National Geographic or, things that you're passionate about, help prove the case so we can make positive changes in the world?
Yeah, it's a great question. I'll share an interesting statistic that I learned a few years ago in my career. Whilst human beings can understand conceptually the world and can care about it at a conceptual level, we typically only do things if they're going to have a direct impact on us. And you care about things that are happening within 30 miles of where you live and where you grew up. And I think for me that's the opportunity, is that if you can harness the power of blockchain to enable citizen scientists, if you can get people thinking about and caring about the data for their neighborhood and their community, then you can get them to care more about it. And I love this idea that through the technologies that we're talking about today, wouldn't it be wonderful if every morning when a child woke up, they went to a dashboard and it told them, how many insects are in their neighborhood and what's going on in their location from a temperature perspective and what the air quality is like in their neighborhood. And I think that if we can make that something that is relevant to people in their daily lives, we're more likely to be able to incentivize them to actually do something about it. And that, for me, is the power of what we're talking about today. It's all anchored in location. And location is one of the ways in which human beings can conceptually connect themselves to the world. So being able to connect the data to the location makes it easier to connect it to an individual human being. And I feel passionate about that.
Ari, can you talk more about the validation or the validity of that data? We always hear fake news, and if it's going to be used, as Marcus just explained, and be collected as Cameron just explained, how do we use your data from XYO Network to keep pushing forward this agenda of non-fake news, for example?
Also, the way I look at it is that, by definition, reality is whatever the majority of people's perception of reality agrees it is, right? So what's true is it's a consensus, basically. So if the majority of people in either a group or an area or in the world agree something is true, then it's true. And so the way that the data for XYO works is we basically interrelate all the data, and we have these bound witnesses. So we have one giant, massive cloud of data. And so if you have a subcloud, you can have a subcloud if you want to have it just in your house and it basically doesn't interact with the rest of the network, that's fine. But now you have basically a local truth, and it's only valid for yourself. And that the consensus of the people in your house who agree on that, that's the reality for you there. That's not necessarily valuable for the rest of the cloud if it's not interrelated to that. But the thing which is nice about having this giant cloud is any anomaly, because really our system is a large anomaly detector, and what we want to do is we want to remove anomalies. We want to be able to either see if they're valid or if they're invalid, if they're Byzantine. But it's really, really, really hard to fake the data in a system if you have to go and basically rewrite the system and all the data that's in there to actually have 51% of the data support your conclusion. So if you have billions of data points to actually float fake news or fake data or that sort of thing, it becomes prohibitively difficult. But like anything, this is more of like a calculus problem, right? The certainty of data is something which will never be achieved. Do we even know whether or not we're in a physical world? We don't really know, so we can't be certain of anything. But what we can do is we can agree that the certainty of data is approaching certain, approaching 100%. So we can never reach 100%, but if we can get to 99.9%, it's a lot higher than the certainty that we have right now. So that's really what we do. We take all this interrelated data and come up with effectively a consensus of where all the data support each other, and any outliers are basically detectable.
Ari, just to switch gears for a little bit, could we talk about a little bit of the hardware that we have in-house right now, the Sentinels, the miners, the coin app that XYO has, and how it's being used? And
Sure. So we started off with location, and the reason for that is because to tie all this stuff together, you have to have an X, Y, Z, and T coordinate for the metadata. So our current hardware, basically, what it does is it does a handshake, and all it does is it stores the relative position between the two different devices. Like in Bluetooth, for example, it's an RSSI, so how far apart are they? It's a vector in some random direction. You don't even know which direction it was. You just know that you were within, say, 20 feet of something else. So our current system is really the underpinnings for storing all this data and how to build out this network of metadata and be able to link them all together with a relationship, which is with their relative position in time-space. Once we have that, which we have now, what we're starting to do is we're working on adding other heuristics. So for example, you can add temperature, you can add the battery level of your device, you can add noise levels, you can add all these other heuristics to it, and we have this connection of time, space, location between all of them. So now you can actually look at all those different things that are there, but more importantly, you can also have cross-references. So if there's 3 or 4 or 5 different things that are proven to be in the same area, taking the same reading, if they all agree, then the odds of that reading is a lot higher. And the larger the network is, it's kind of nice where you have a network effect. The larger the network is, the more dense it is in certain areas, the higher the certainty goes. So the goal is to basically, approach infinite certainty in all these different things, but you have to have infinite data to have infinite certainty. So our hardware basically is to start that off and to get the relative location and be able to build out a larger and larger network between our phone app and between the physical hardware. All those things are adding nodes to our network.
So there's a booth upstairs, XYO booth, so if anybody wants to go check out some of the things and products that XYO provides, is manufacturing right now. You can see the Sentinels. They are beacons of location. You can download the Coin app and mine different location data, earn some XYO token, and just talk to the devs up there. Some of the, and Ari's around, you could talk to them. Last question, fun question, simple question. What would you like to see hacked here at Denver? And maybe in relation to your business or your companies or just maybe your passions. Cameron.
Yeah, again, I think proof of location is kind of the fundamental, or like one of the fundamental pieces of metadata that contextualizes everything else. And so actually, like, some of the simplest use cases are some of the most interesting, I think, specifically around asset tracking or tracking of supply chain logistics. Something around that would be really interesting to see with the proof of location there tied into it. Again, if you're fishing tuna and you're trying to prove that the tuna that you fish came from a sustainable part of the ocean, something like that, right? Right now, some of the applications that we've seen around, within the blockchain space, the fisherman is entering in the proof of location, or they're using GPS or something like that, but it's still a very manual process, so maybe something that kind of abstracts some of that. Yeah, something around that.
Hey, Marcus, do you think they could start tagging the fish, maybe? Tagging the animals?
In fact, we're actually working with Google to do that, using AI, being able to identify species. But what I would love to see here at the conference would be, I think gaming is the answer to everything. I'm a huge gamer, and my belief is that one of the ways to win people's hearts and minds is gaming. And I think that something that ties location into a really great gaming experience, building on the sort of principles that are in the Coin app, I'd love to see what people can do to, like my wife, if she plays Candy Crush, if you can come up with a game that somehow integrates blockchain principles and gets her participating, she's a machine. So I'd love to see some developments in that space.
We have a few bounties also, I think, for the hackers upstairs, and a lot of our bounties are around the Ethereum integration for our system. So one of the things that's interesting about our system is the data, the way we have it stored and everything, is not specifically on Ethereum or on a blockchain. It's data which by itself can be analyzed on its proof of origin chain and used either through an API or through a smart contract. But our integration into Ethereum is something to be used with the smart contracts, and I think most of our bounties here are revolving around that, whether it's the UI for how a person will be able to call the smart contracts, actually integrating with the smart contracts and being able to query our system through the smart contracts. So I would love to see some good steps forward on how to actually use our system through the Ethereum network from the hackers here.
Right on, gents. Thank you very much for coming on the panel. And once again, you can go up to the booth, check out the Sentinels, download the Coin app. Some of the leaders of mining location data have earned over 300,000 XYO token. The second place person is like 100,000. The third place is 60,000 XYO token. So it's a lot of fun. Check out the app, check out the devs up there, and say thank you to Ari Tro, Marcus East, and Cameron Strog. Thank you guys.